right. Hello, everyone. Thank you for joining us today. I am Farshad Tabakoli with the Mender team responsible for technical product marketing. With the release of 2.7 just this past April, Mender expanded beyond OTA updates and introduced optional add-on packages that contains a set of features for solving other device management use cases, such as troubleshooting and configuring devices. These add-on packages will give an expansion path to users and customers of Mender to enhance their device fleet management capabilities. This webcast today will demonstrate these features to our valued Mender users. Additionally, we will also cover Mender 3.2 or 3.0, which was released just recently. We will spend about 45 minutes on demoing, and then about 15 minutes or so, we'll open it up for any questions you may have about the content that we will go through today, or anything else about Mender that you'd like to know. For this reason, we graciously ask Mender CTO and Product Management Øystein Sternberg to give us this demo webcast today. So I would highly encourage you to take advantage of this opportunity and ask any questions you may have about Mender. If we do end up missing any questions from the audience due to time limitations, we will make sure to reach back out to you with the answers. So with that, I will pass it on to Øystein. Taking it away, Øystein. Thank you.
Hi, everyone. Thank you, Farshad. Thanks for joining, everyone. As Farshad mentioned, if you have any questions, just type them in the chat, and we will handle it towards the end. So I will start with the agenda here, and we'll cover Mender 2.7 first. So what's new in Mender 2.7, which was released in April? There are two main add-on packages that we added. The first one is Troubleshoot, and the second one is configuration. So I'll go through those, what they are, what's the purpose, and also show you a demo of each of them. Then I will cover Mender 3.0 as well, probably a little bit more quickly because it's quite a bit of content here. And but I hope to also show a demo what's new in Mender 3.0. And at the end, we'll have 15 minutes for Q&A, so please sit back and type down any questions you might have along the way. So as Farshad mentioned, we are introducing device management add-ons in Mender 2.7. And this is, the purpose is to cover basic device management need. So obviously you could say over-the-air updates is device management use case as well, but even outside the scope of over-the-air updates. So this is due to feedback from many of our customers, probably many of who are on this call today. So thank you for providing us feedback, what's important. What it does, it eliminates some extra tools, especially homegrown solutions that you need for basic device management. So for example, things like a remote shell or remote terminal was a pretty common pain to invent in addition to having Mender, but now we'll reduce that friction. These are structured as add-on packages to Mender. So this means that they are completely optional. So if you want to keep Mender pure OTA as it is today, for whatever reason, if it's security, privacy, or you don't need anything else, you have your other device management use cases solved already. You don't have to add these to the Mender stack. So they can be removed both from the device side and the server side. And you can choose the ones you need. So for example, in the two first ones with troubleshooting and configuration, you can pick only troubleshooting, for example. So if we look at what's in 2.7 and what are the features, we have the first add-on package, and the package itself Troubleshoot is meant to resolve support issues real time in a secure way. So the typical scenario here is that you have some customers using your IoT product, your devices, and maybe they reach out to you that there's something wrong, or you figure it out yourself that something has to be looked into. So the package name should be quite descriptive that way. But the features that it contains is a remote terminal, a session log for the remote terminal, file transfer, and port forwarding. So we'll cover those in more detail in the next few minutes. The second package is configuration. So this allows you to customize each device to its environment. So as you know, Mender as an OTA solution is very good at keeping things consistent, keeping the same software running on all the devices or all the production devices. But sometimes you need to set some specific settings on a specific device, smaller configuration settings. And this is what this add-on package covers. So there is a UI, a reporting of the configuration, and the scripting interface. And again, I'll cover this in more detail a little bit later. Both of these features are backed by an audit log. If you have Mender Enterprise or using free trial, you have access to this, meaning that it generates an audit trail, what every user of the Mender server does to each and every device. And it's also backed by role-based access control. So you can set up rules for which users can do what to which group of devices. So we take security very seriously, obviously. In particular with troubleshooting remote terminal, this is usually the first or top of mind. If we look at the remote terminal as the first feature, it's secure and customizable. The purpose is to quickly troubleshoot and fix customer problems. I'm sure you're familiar with the use cases or the need for having a terminal access now and then to your devices. Things happen that you didn't predict. So you just need some way to figure out what processes are running, for example, and do some hot fixing. The remote terminal in Mender, we focus on security. So there are no open ports on the device. It utilizes the existing credentials that we use in Mender and uses a WebSocket connection to connect to the server. So you don't need to expose any ports. It's covered by audit logs and role-based access control, like we mentioned. And you can select which user it will use on the device itself. So you don't have to, or actually you shouldn't give access to the root user through this. You can choose a more restrictive user. So even to add extra layers of security. It's also customizable. You can select the shell, the user to run as I mentioned, and it uses minimal bandwidth. There is a web and command line interface available. So the web one is through the familiar Mender UI, but also there is support for it in the Mender CLI utility. So if we compare this to the most common solution or partially homegrown solution is seen in the field, which is VPN and SSH combination, you can see that there are both security and customizability advantages to the Mender remote terminal. Of course, you can always implement these features on top of SSH, like an audit log probably, but what we're trying to do is to help you avoid building homegrown solutions. We also back it by the audit and session logs, like I mentioned, and so you can see who connects to which device. After the fact, you can actually see what happened inside that session. So what did that user do to that device? These are enterprise-only features, and yeah, also available in the free trial if you want to test it out. File transfer feature. This complements the remote terminal. As you're familiar with Linux, you probably know SSH and SCP, they often go together. In terms of troubleshooting, you typically want it to copy diagnostics information from the device. This could be, for example, log files that are too big to look at inside the remote terminal, or it could be stack traces, core dumps, things like this that you want to copy down from the device. But you can also copy the other way around. So you can, if you have applications and you need to fix them very quickly on that particular device, you can copy the new application down, or diagnostics tools, for example, debugging tools. And with that, I will show you a demo of all these features. So I do have a hosted Mender setup here, so you can get the same if you just sign up for hosted Mender through the free trial and install on device. But if you now look at the device information, you select the device, you can see that these troubleshooting features and configuration features are available. So the remote terminal, you can connect pretty quickly and look at the terminal like you would normally do. If you have a core dump or something you would like to copy down, you can I can use a trick here, but this is where systemd places the core dumps. You can actually click on the file path, and it will download that core dump, as you can see. So this you can do with any file as long as it's the first thing in the terminal, basically. That's why I'm using real path here. But you can also upload files to the device itself by using this dialog. This is also available in the CLI, Mender CLI interface, if you prefer to use your own terminal. Now, if something happened to the device and you're not sure what was going on, you can look at the audit log. So you can see the actions that have been carried out by users. In this case, it's just me. But if you have a terminal session set up, you can also look up the session log. So you can actually replay the session that I just did. So it will populate here. So that was the troubleshoot package, at least the demo of it that I was planning to cover. There is one more feature which I won't demo, but this is port forwarding. You will need to use Mender CLI for this. You cannot do it through the UI directly, just the way the architecture works. But this allows you to test connectivity or responses as they are seen from the device. So you can, for example, see how connection to the backend that you might have is working. What does the backend respond if you connect as the device? But also a very common use case for it is that you have an admin panel running on the device itself, a bit similar to what you would have on a consumer Wi-Fi router, for example, where you connect to 192.168.1.1 or something like that. Now you can also connect to that such admin panel web interface remotely through the Mender port forwarding. And you can support customers configuring their devices through that admin panel. You can even connect through that device and to other devices on the network that you might have. So this could be sensors, for example, that are connecting to the Linux gateway. There is also role-based access control for troubleshooting. So there's a new role called troubleshooting that the user needs in order to be able to use the remote terminal like you saw I did, or the file transfer, or all these features. So technical support is the main candidate for getting this role. But they, at the same time, probably don't need the permission to deploy to all devices. So this is a separate permission, the OTA deployment. Okay, so now we finished the troubleshooting. So I'll take a look at the configuration add-on. And if we start with why you would want to use it. So overall, it's to improve the customer experience. So you can tailor the device more to the customer and enable faster support. So customizing the device to its environment, this is to basically to set unique attributes to a device. Complements the software updates, which is more about keeping the device software consistent. Typical use case is to localize the device, which could be the backend. So it should use a different backend if it's in the United States versus in Europe, for example. And credentials often go together with that. Or it could be the time zone as well, based on the location of the device. Or if you have a device with a display, you can change the logos or menus if it's used in commerce for the device nightly, let's say, through a deployment. Or support use cases could include also license enforcement. So you have a customer that bought entitlement to 5 speakers, for example, in a smart audio system. You can use the configure add-on to actually enforce that this specific device has or is able to use 5 speakers. Or you can enable debugging in your application too, if there are any, if you suspect there are any issues with it. So overall, improved customer support is what I would say configuration is about. Oh yeah, I can actually show a demo before I go further here. So let me jump back into the environment here. If we go to the same device, it will also have the configuration, device configuration available. So like you can see now, the time zone is set to Tokyo. You can verify that with the remote terminal. So it's probably Japan summertime. But you can change this. So let's say we use Europe Oslo. You simply save and apply this and wait a little bit until the device picks it up. It should only take a few more seconds. So you can see now that it's been set to Europe Oslo, and you can also verify it with the date command that it's now Central European Standard Time. So just diving a little bit, this looks maybe like magic, but if you're interested in the details or the architecture of it, it's actually quite simple. So there is a file that gets copied down. So this is, if you recognize, this is the same as I have in the UI. So it's being copied down to the device, and then a set of scripts is actually being run. So all the scripts in this directory, and you can see there is one called time zone. If we looked inside this, you would see it's using the standard system utilities to set the time. So it's very flexible, customizable, and extensible. So you can integrate this also with your own application and how that application is being configured. So let me go back to the presentation again. Yeah, so this is basically the overview of the architecture. I explained it a little bit using the remote terminal, but once you save the configuration, it's being copied down to this JSON file. Scripts are used to apply the configuration, and then it's being reported back what's the actual configuration. So Mender keeps track of what's the actual reported configuration versus what's the desired as well. So in this sense, it's behaving a bit like a digital twin. Okay, so now we move on to Mender 3.0. This is actually going quite well with timing. So the main challenge that we're trying to address with Mender 3.0, I'll try to explain here in this slide. So it's a scenario where you have a product and it can contain several devices. This could, for example, be a building where you have many heating systems that need to stay, that behaves as a system, basically, and they need to stay on the same software version. Or it could be within transportation, for example, a vehicle has several Linux devices and they need to stay on the same software version as well. So it could be many different scenarios, but you need them to work as a system, this set of devices, basically, or group of devices. So you want to upgrade all of them from version 1 to version 2, let's say. So the constraints you have is that it needs to be an all or nothing update. So this is due to the dependencies. So it's not the case for all IoT devices out there that these constraints are present. And maintenance windows needs to be short. And the environment is unreliable, so power network can be unreliable. So if this fits the environment or use cases you have, what we have in Mender 3.0 will probably be interesting. So what can go wrong here if you have these constraints is that you could have one device rolling back to version 1 and one is installing, and then your maintenance window ends, and now this is an inconsistent environment. It's a mix of version 1 and not done and version 2 devices, so it will not work well together. Oops, and I'll go one back. So synchronized update is the solution that we have in Mender 3.0 for this. It's a new feature. What it does, it allows you to pause when reaching a certain state of the update process. So if you're familiar with multi-threaded programming, if you've been doing some of that in the past, you might remember barriers. And this is very similar to what a synchronized update does. So I'll try to illustrate it here with a workflow. So let's say you have 5 devices. The first state is to download the new software to the devices. And this is also the first place you can set a pause or a barrier. And then you can choose to wait here for all the devices to finish the download before you continue, or you can continue if 4 of them have finished it, for example. That's up to you. But this is, the way you can synchronize it. Then the next state is install. And you can also set a pause after it has been installed. What happens here is that basically, if you're doing root file system updates, it switches from the active to the inactive partition, the newly updated one. So next time it reboots, it will get a new update. If you're doing application updates, update modules, it will install the application. Then reboot. This only applies to system updates and commit. So there are basically 3 different places you can set a pause here. And the purpose of doing this or doing it in these different states is a little bit different. So I'll try to explain that as well. So basically, the first one, the reason you would set a pause between download and install is to shorten maintenance window. Because imagine you can start the update safely on Monday morning to all the devices. It won't have any impact on the fleet. It will use some bandwidth, but that's the only impact it will have. No new software will be installed. So you can do it at any time. Just wait until all the devices have gotten the new software before you proceed with installation. So that's when your maintenance window starts, when you install it. So that can make it a lot shorter versus if you have to have the maintenance window on Monday morning until all the devices have downloaded and installed it. That's going to be a much longer maintenance window. The next place I'll explain the use case for is between reboot and commit, because these two things or these two places relate a bit more to each other. So if you put the pause here, you can ensure consistency, do quality assurance. So if you are close to devices, you can see the metrics coming back from them, because after when you are in this stage or between reboot and commit, the devices will be running the new software. So you can check them, make sure they are working correctly, all of them. And you can also give the user the option to roll back. I'll talk a little bit more about this later. But yeah, so this relates a bit to each other, shortening the maintenance window and ensuring that things are consistent after the update. So making sure you stay within the time frame. And the one in the middle is more relevant for enabling the user to control the update, because after installation, but before you apply or reboot, the update will be installed upon the next reboot. So the user can reboot the device himself and he will get the new update. Okay, so I'll show a quick demo for this as well. So if I go back to the environment here, I have created a group here that has currently 3 devices. And they're running the same software just like we want in this use case. They need to stay consistent. But now we have a new update that we want to deploy. So we want to update to version 2 of this UI application here. And this store 451, that could be a building, for example, maybe in commerce, where you need this to stay in sync. So they are co-located typically. So if I go to the deployments, I can set up the deployment. So I first select the group and the software. So it's the new version of the software. I won't do a rollout schedule, but here's the new feature of Mender 3.0. So I can add this process. I will add one before installation, so I make sure that all the devices have the software before I start the installation of any of them. And then I'll add a final also for before the commit, so I can make sure that everything is successful before I actually make this update permanent. Okay, so let me continue. So now it's going to pick up on these devices. Let me see. And a couple of them have picked it up already, but I don't want to continue yet because there's still one missing. Okay, so now all of them have downloaded the update. And it will pause here. So it's paused before installing now. I can now wait until a maintenance window. So maybe it's not until Wednesday, so I can leave it like this. But in my case, of course, you're not going to be here until next Wednesday. So I'll simply continue this update now. And we will see what happens. Remember, I set another pause before commit, but now you can see we're out of luck because there was a failure here, and we're in the middle of a maintenance window, so I'm not really sure what we can do here. I can look at the logs maybe, but it looks like there is some abnormal exit here. I'm not quite sure what's causing it. I don't think I can fix it before the maintenance window actually ends. So now I'm in an inconsistent state, almost out of maintenance window. There's not much I can do here, but luckily I can abort it. And if I do that, you will see the deployment going to finished. And if I look at the details, you can see they all either failed or aborted. So in the overview, you can see there's 2 that skipped the update. That's because I aborted them. And now if we look at the devices, let me see, there they are. You can see they're still on this old software version. So the ones that finished update, they rolled back because they didn't, I aborted them. So they went back to the old version. And the one that failed to install, it stays on the version that it had. So we're still in a consistent state. We have to retry it sometime later, maybe look at that log again, try to figure out what's wrong, connect the device, and try again once we know what's wrong. But at least the system remains consistent, and no customers have been impacted by this failure. Okay, so that's synchronized updates, and I will, let me see, go to the next slide. Oops, yeah, so this is the device-side API. So this is an API, as you can tell from the name, that you can use on the device itself. So it gives control of the update on the device. So this is actually what Mender uses, the Mender server uses in synchronized update. It talks to the device and uses the device-side API to tell the device when to move to the next state. But this is now also exposed to applications running on the device. So use cases you can enable for your customers is to, if you have a display device, for example, or some interface, maybe through mobile, that the user can interact with the device, you can enable or disable updates. Or you can ask the user, okay, now we updated, would you like to keep this version, or would you like to roll back, just like I did in a synchronized way? But you can also do it on the individual device level with the device-side API. So it's implemented through DBus, like I mentioned, and you can leverage it in any application that runs on the device. Typically, this would be a UI interface that you have on the device that would use it, that would talk to the user and then relay those answers to the Mender client. And we also plan to extend this DBus API in future releases of Mender, so you can get even more control over the update process on the device itself. Yeah, so these are the kind of features you can show to your users to enable automatic updates or not, or make the update permanent after the update. So, and the automatic update option can be useful if devices are going through some critical work and they should not be interrupted with an update. You can disable updates altogether, or your users can. The last feature I wanted to cover in 3.0 was a new UI that we have for devices, also based on a lot of input from you, probably many of you on this call. So we're now giving consistent filtering across authentication states and batch operations when you select devices. So for example, one use case is to filter your rejected devices. This wasn't that easy or consistent in previous releases. So some sometimes you get a lot of rejected devices or pending devices, and you want to accept one of them or decommission one of them or accept 5 of them. And these kind of operations was a bit cumbersome in previous releases, but now it's been unified. So you can see that we have gotten rid of the tabs that we have in the devices UI. So now it's a filter rather. So you can select the authentication state. So you can see all the devices, for example, regardless of state. And you can also see, some of these are accepted, rejected, and you can filter on rejected devices, for example, with a given MAC address. So hopefully this will be a welcome usability improvement. And thank you for the feedback that has led to it. We're actually going towards the end of the presentation from my side. Here are some links if you want to try out the new features. Like I mentioned in the beginning, you can try all of this if you just sign up, go to hosted Mender.io, choose sign up. If you're new to Mender, I'd recommend to start with the get started. It would also cover the sign up process, which is very easy. And then it will take you through installing the device software and everything you need. The new add-ons in 2.7 are covered in a separate chapter in the Mender documentation. So you can go to this link if you want to read more about those, or get them installed. If you already have a Mender installation, you want to try out the add-ons, you can go there. It's usually easier to try with a new device, but you can also add this to existing devices. And lastly, we have in the overview a new document about the customizing the update process, which will cover synchronized update and the device-side APIs. With that, I believe we have reached the Q&A section. So we're running 7 minutes ahead of time, it looks like. So we will have time for some questions. And I will give it to you, Farshad, if you have gotten any questions so far.
Yes, thank you, Einstein, for that. Yes, everyone, please, if you have any questions, use the chat box and we'll try to answer them. One question is from Johan. We are currently on integration 2.6, Mender client 2.5. If I want to move to 2.61, 2.71, or 3.0, should I update devices first or server first? I guess server first, but just to be sure.
Server first is the safest option. We are generally very careful with backward compatibility. So for example, if you were to connect an old Mender client to the new Mender server, it will fail when it doesn't have the features that's required, like the synchronized update. And if you have a new server, it will support the old device-side APIs. So in general, I would recommend upgrading the server first, and that's what we do with hosted Mender 2 as well. Obviously, we update that typically monthly, and we have a wide range of device client versions, obviously, from all our customers. So that's well tested.
Great. The next question is from Drew. Is the continue or abort on synchronized updates scriptable? Can I run a script somewhere to decide, or does it require operator intervention?
You can run a script. So you will need an application that connects to dbus. So synchronized update, if you heard about state scripts, this is a separate feature, and it can be a little bit confusing. what to use. So if you just need to run a script between, I don't quite remember which state it was, but was it after install? If you just need to run a script, then I would use something called state scripts in Mender. These are much easier and better if you don't need intervention from the user or the operator, meaning, for example, you want to migrate some data to a new configuration format, or you want to do some checks after you install the update that should be automated, then use state scripts. If you're dealing with users, they need to have give some input on the device, or you want to have control over when the devices update or reboot, then use the synchronized update or the device API. So yeah, I hope that answers your question.
Great. The next question is from Vincent. Could you detail the difference between the new device API and a custom update script? As far as I know, they already had access to Mender client state machine to alter the update.
Yeah, exactly. So I covered it a little bit in the previous question. So the state scripts are better for automated processes. So if you don't need any user yourself included and to make any decisions, then use state scripts. The reason is that when you're working with users, it's not very predictable when things should continue. It might say you might have to wait for a very long time, and state scripts aren't very well suited for it. They have a timeout, so you should know in advance if you use state scripts how long you would expect to wait before you abort the update. And the other thing is that with the new device API, you obviously have more control. You can you can ask the user, and you can depending on the answer, do some logic, and then decide what to do with the Mender update process. So I hope that answers. But I do understand. We also have in the documentation some example use cases that would better suited for state scripts versus the device-side API. That will help to clarify, I hope.
Great. Another question from Fabian. Mender 3 client seems to only be available for Yocto Dunfield version. Will it be available to Yocto previous releases, Warrior, Zeus?
Yeah, this is a good question. I don't think so. So typically we officially support only the newest LTS of Yocto when we release a new version of Mender. So this will be supported. When it comes to older versions, I believe we try to support the previous one. So the one before the current Yocto LTS. But it's also documented in, if you go to docs Mender.io overview and compatibility, it will give you a matrix which Mender version supports which Yocto version as well, so you can check there. But in general, we cannot maintain support for all Yocto versions for all Mender versions. So we focus on the latest Yocto release with the latest Mender release. But if you are interested in contributing support, improving it, we're definitely very welcoming in supporting all older releases of Yocto as well in MetaMender.
Great. Another question from Johan. He says we are using Mender open source on a Google server. We would like to switch off the server to save some money. what would happen to the devices when they'll try to communicate with it?
Yeah, so they will fail connecting, obviously, when it's off, but they will keep trying forever. So as long as your URL, so in Mender conf, etc Mender conf, you have set a URI to the Mender server. So as long as that one becomes accessible and you have the same certificate on the server when it comes back online, your devices will simply connect to the new server. And even if you lost track of them, so to speak, they will request access again. So as long as you maintain control of the domain name, that's the most important thing, and the devices will keep trying to connect.
Great. Another question from Tommy. Is it possible to configure port forwarding from the device API?
Let me see. No, that's not possible currently. This is something that you do on demand from Mender CLI. So when you want to do port forwarding, you run command line utility on your laptop or workstation called Mender CLI port forward. Then you specify the remote and local port. So you want to forward. Mender CLI will connect to the Mender server, authenticate you as a user. Then the Mender server will connect to the device. So there isn't any device configuration that persistently forwards ports. It's the purpose is more for troubleshooting, so that you can get access to the device network on your laptop, let's say, to troubleshoot or diagnose, and then you shut down the port forwarding afterwards.
Excellent. I think there's another question from Fabian. Did you perform, or is it planned to perform some cybersecurity tests on the Mender client, pen tests, fuzzing, or bug bounty, in order to ensure that it is robust to cyber attacks, mainly for the troubleshooting feature?
Yeah, so we do have a strong security policy and a security team. So there are several layers to this. We do have a bug bounty program as well. We're getting reports there and fixing issues as they are reported. We did recently a security audit by an external company as well. So this is also probably a few months old now, maybe 1 month old, the latest audit that we did. So we do take security very seriously. And for enterprise customers, we can also share some findings and reports of these audits. But in general, they have been, very good.
Great. I think we have a few more minutes, folks. If you have any more questions, I think we still have a little bit more time. Feel free to send it to the chat box. If not, actually, I have maybe I have a personal question myself, Einstein. From what I understand, one of the most important reasons you'll likely consider port forwarding is to enable remote SSH or VNC connections to your device. Can you elaborate, like, the difference between using that feature and the remote terminal?
Using the difference of using
a port
SSH
forwarding, yeah,
or VPN is what you mean, maybe.
yeah.
Yeah, so with VPN, you get access to the entire device network. It's more of a it's a larger infrastructure to set it up. So that's more of a permanent network configuration, whereas that's also uses more bandwidth, and you need to set up keys, and it has quite a bit of overhead, but you get a permanent network connectivity. So the port forwarding we have is more intended for shorter term, like if you have specific queries, or you're investigating something on the device itself. So it's no infrastructure overhead. If you have Mender already, it's all there. But wouldn't recommend it to set up like a permanent network connection there to forward traffic to the backend, for example.
Got it. Thank you. I think we have a couple more questions. There's another one from Tommy. Are there any pricing info on the add-ons? I think I can answer that. Yes, you can read that's on our webpage, the pricing page that you can there's a calculator that you can use, and depending on the number of devices that you have, that gives you some idea of what that is. Another questions from Johan. When you said they'll try to communicate forever, will they try more often when it failed, or will they keep trying with the same pool interval set in the mender.conf file?
So in general, there is exponential backoff, like you have typically for any web client. So there's a pooling interval, and let's say it's once every 30 minutes. So that will always happen every 30 minutes. But it will also retry. So if it connects at the top of the hour, it fails, it will retry 3 times, I believe. And it will have an exponential backoff there, depending on the frequency of the pooling. If the frequency is short, like the retries will also be quick, but they will still be exponential backup. And this is to avoid the situation of denial of service, obviously, unintended, that once some part of the Mender server starts to be overloaded, you don't want all the devices to be more aggressive. You rather want it the other way around.
Great. Another question coming from John. What are some new features, improvements that are on your roadmap? Also, the new features plus UI in 3.0 are really awesome.
Okay. Thank you. I cannot share too much about the roadmap, but we have one last device management add-on that we're planning to add around monitoring. And this is planned for the next release. So it's probably going to be a few months away. And that's, I think, what I can share here. So thank you for the feedback, and I hope you enjoy the new features as well.
Great. Any more questions? All right. I think this can conclude our webcast for this series. I hope everyone. We have another question from Mauro. I think we have a couple more minutes here. Hello, Einstein. Is planned to implement an automatic binary delta generation feature that work in background server side without relying on Mender binary delta generator?
Yes, so that's an item on our roadmap. So this we will release. I don't have an exact ETA for it, but this is coming.
All right. He says, thank you. Awesome. So thank you. All right. We'll just give it a couple more seconds to see if everyone else has any more questions for Einstein. All right. Thank you so much, everyone, for joining us. Thank you for all those good questions. We're always here to answer any questions. Please reach out to us at any time. And we hope to see you soon again. And that concludes our webcast for today. Thank you, Einstein. Thank you, everyone.
Thank you.
Bye-bye.